Good morning. How's everybody doing? Got a full house. I guess everybody's interested in pump repair capabilities of Kentucky. I want to thank you guys for choosing this session. I'm Isaiah Willis. I'm the operations manager for HECO Kentucky Service Center. I did want to start out, quick show of hands, who was aware that HECO had a Kentucky Service Center? Okay, that's awesome. A lot more than I expected, actually. So the sales guys are doing a good job. So basically this session, I want to give you a quick down and dirty, what we can do, what we're good at. Aside from pumps, of course, we do motors as well. So we are a full-service electromechanical repair facility. Formerly Kentucky Service, founded in 1968, so we've been around for a while. HECO acquired us in May 2021. We are a fully accredited ESA member. Being fully accredited is different than just being an ESA member. Basically, this means that we're held to the AR100 standard. We are audited both internally and externally, so that ensures that our test equipment, from calipers, what have you, we are conforming to that standard. We do have a 4160 volt test panel for our motors, in-house machine shop, CNC, lathe, mill. I do have 8 repair technicians and a 2-man field service team. 2-man that's dedicated. If I need more, we pull other guys. Types of pumps we repair. When it comes to what we can repair, we are not limited to specific types or brands. We do have relationships with most of the biggest names in the industry. But this does include vertical turbine pumps, ANSI or process pumps, rotary lobe, air-operated double diaphragm, submersibles. We can do it all. We will dig into more vertical turbine talk in further slides, but the key difference between a centrifugal and positive displacement pump, centrifugals have impellers. PD pumps, they move the fluid with gears, rotary lobes, or air diaphragms. PD pumps also deliver a more precise flow rate compared to a centrifugal pump. So depending on what you're wanting to achieve with it, that'll be a big factor. Our in-shop repair services are backed by technicians with decades of experience. It's our standard operating procedure to document all mechanical and electrical checks during disassembly through a software we call Go Forms. This is basically a checklist that ensures that every mechanical and or electrical data is recorded along with photos of each step of the process. Go Forms is something that HECO developed, by the way. It also ensures each piece of equipment that comes into our shop is subjected to the same rigorous standards based on that ESA AR100. After repair or replacement of worn parts, if the pump is fitted with a mechanical seal, we will pressure test the case up to 15 psi for 30 minutes. We also offer 24/7 on-call service for those middle of the night emergencies that I'm sure we all know too well. Our field service team is extremely critical to our customers. There's a lot of equipment that cannot be pulled from service. Examples of on-site repairs that we would commonly perform: repacking a pump, shaft alignment, bearing installation, or oil changes of an electric motor or a pump. And also the field service crew is on call 24 hours as well. Predictive and preventative maintenance. This goes hand in hand really with our field service. This could include quarterly plant walkdowns that we do for our customers. Basically, we send a couple guys in. They can give us a list of assets that are critical to their operations. We will do visual inspections for leaks, misalignments, audible cavitation of a pump. Our Apollo program, I'm sure most of you all have probably heard a little bit about Apollo, is well suited to catch failures on pump bearing frames or the driver of the pump before they occur. It's important to note, much like an electric motor, one of the most common pump failures is related to bearings. Pumps have a multitude of bearing configurations, such as oil lubricated bearing frame on an ANSI pump, or water lubricated bronze or marine cutlass bearings in a vertical turbine. If the bearings fail, the shaft drops, you can destroy impellers, the housing of the pump, break the shaft, other aspects of catastrophic damage. So take care of those bearings, fellas. Vibration analysis and infrared thermography. Vibration analysis is a great tool to identify impending bearing failure in a bearing frame of a pump or worn bronze bearings in a vertical turbine column. If a bronze sleeve bearing are worn or egg-shaped in a turbine, this will allow that shaft to whip, and depending on the length of that pump or vertical turbine, this can really have a compound effect. In a future slide, we'll actually see some real-world field service repairs that we've done, and that pump is roughly 65 feet long. Vibration data can also help trend failures for a given asset to determine root causes of repeated failure. Of course, infrared can pinpoint hotspots throughout any mechanical or electrical system and is also a great resource that we can offer. Equipment removal and installation. At HECO, we really do. We strive to be a total solution provider and offer turnkey removal and installation of repaired or new pumping systems. When installing a new pump, pouring the concrete housekeeping pad and properly leveling a sole plate or a base plate is critical to the life of that pump. For example, if a vertical turbine is installed out of level, that axial or downward thrust is created. That's going to put a side load and strain on the pump columns, the shafts, the bearings, leading to premature wear and potentially destroying a very expensive new pump. Ensuring that that base is completely grouted ensures that that thrust and that vibration is evenly distributed on the plate. There's harmonics that actually come into effect from a vertical motor. From the coupling, it's traveling from that motor frame through the coupling. Actually, what it's supposed to do is transfer through the frame and then get dissipated evenly through a sole plate or a base plate. Excuse me. And here, you've got your concrete layer, typically 6 to 8 inches, depends on the weight of the pump. Then once the plate is actually set in place with jack bolts, you're going to want, we like 1.5 to 2 inches of grout. If the base plate does not have holes cut in it to pack the grout, then we will actually mix it to a more watery consistency to where we know that that flow is completely under the base plate and there's no air pockets. There's been plenty of removals where we've taken out old equipment and you've just got gigantic air pockets, and that's a bad installation. System design and upgrades. Pumps are sized based on their flow and head rating. Gallons per minute is the most common unit of flow, and total dynamic head, or TDH, is rated in feet. There's many factors to take into account when determining what type of pump to use for a given application. Big question I always ask first, what are you pumping? This may seem obvious, but without knowing viscosity, temperature, pH, or if there are solids in the fluid, that's critical when selecting a pump. Any corrosive or high sugar content in the fluid would also call for a special metallurgy. Cast iron, most commonly, manufactured in pumps, that can just get eaten up with a high sugar fluid. Say you're pumping mash at a distillery, you're going to want a stainless pump. Clean water applications, cast iron is totally fine. Any special metallurgy, like I say, if you need something stronger than, say, 316 stainless, there's CD4 MCU, which makes things very expensive at that point, but that pump will stand up to the corrosion. My next question is, where are you pumping to? This is taken into the account of the suction side of the pump through the discharge all the way to the final destination. Things like pipe diameter, valves, or other restrictions in the fluid path, like elbows or tees, create frictional loss, which the pump has to effectively overcome to reach its destination. This is the head rating of the pump, which is how high or far it can move that fluid at a given flow rate. And of course, when a pump deadheads, this means that pump is just spinning. You're not moving fluid, you're basically creating heat. Additional repair services include machining replacement parts in-house. It's not uncommon for some of these replacement parts like shafts to have 10, 12, 16-week lead times, in which case if we have it in our shop, I can machine a pump shaft in a day or two. We can restore worn impellers or have one-off castings made of a brand new replacement. We do have a local resource in Kentucky. I can send them an impeller. It's pretty amazing though. They will do one-off castings. That's kind of their bread and butter. Also, we do have hard coating sections of pump shafts that can make contact with the bronze or marine bearings in a vertical turbine, which greatly extend the life of that shaft. This can range from a ceramic-based coating, or it could be something extremely durable like tungsten carbide. Sandblasting and epoxy coating, impellers, bowls, and columns actually improve the efficiency of the pump as well. So here, on the left, you'll see an impeller that's seen better days. Frequently, we actually see this in old, like booster pumps. Obviously, this one's been neglected by maintenance, but that was actually sent out and had a brand new one-off casting made in bronze. Here's an example that I was talking about of thermal spray. So that would be a pump shaft. I believe that's more like a ceramic that's being applied there. Very cool process. So anywhere you have packing that's going to ride on that pump, if you're constantly going through sleeves or if you're just seeing that shaft is getting replaced all the time, it'd be a great option to look into. Here we have what's called Belzona. It's a special epoxy paint that will actually improve the efficiency of the pump, like I mentioned. This particular one is NSF rated, which means that it's okay for potable drinking water application. We did that for a large municipality in Kentucky, and I'll talk more about that in depth later. So, can't mention the customer name for legal reasons, but they do almost all the water for Lexington and the surrounding areas. So really, this section of the presentation I wanted to focus on a more real-world, unique job that we did and how we helped the customer. Large water municipality, they had vibration in one of these 65-foot turbines. HECO went in, did vibration analysis, determined that the pump needed to be pulled and repaired. We came up with a plan. Unfortunately, this pump is not easily accessible. It is right on the Kentucky River, several hundred feet down on a cliff, basically. We'll see some pictures of that. But long story short, we did the pump repair with a barge and a crane on the water, had it back to the customer, and they were pumping water again within 29 days, back to 72 million gallons a day. So here, up at the top, and you can't even really truly see the top, there's a rail car. That's how they have to transport most of the small equipment down to the pump house. This is actually on a secondary landing. He's nowhere near the top. I mean, it's, if I had to estimate, probably 400 or 500 feet, elevation. But here's the pump house. There's 6 vertical turbines in service down there. They call that low service. And again, we're pumping straight out of the Kentucky River. Here you can see the columns of the verticals. And there's actually a caisson for each one of these with a screen. Helps to keep the debris out, fish, things like that. We actually had to employ divers to dive under the caissons, disconnect a bunch of stuff, take off a big basket strainer. and then we were able to start pulling it from the top. But this kind of gives you a look at the magnitude of these pumps. I mean, I think the columns are 65, plus you got the 1,250 horsepower motor that's on each one of those guys. Here, the motor's already been removed. You've got your discharge head. Now there's multiple ways to couple shafts. There's actually a knuckled design where they interlock, and then there's a keyed sleeve that goes over. But in this case, these are just threaded. It's the simplest. I think it's actually the best form of coupling. But each section is roughly 10 feet long. Here, you're going to have that bronze bearing, or actually, no, that's a marine cutlass. Marine cutlass is basically a brass OD shell that you will machine to fit the spider, and then the inside's actually rubber. So, you know, a lot of people may not think rubber's a good bearing, but it's a nitrile, real dense nitrile, and then it's water lubricated, and they actually do hold up really well. Each section of the pump was coming out. Columns, like I say, roughly 8 to 10 feet. The overhead crane in the building gives us just enough room to get the bowl assembly, which houses all of the stages for the pump. Each one of these bell-shaped items here will have a different impeller. And as that pump is pumping, every stage it's getting boosted with higher pressure or head as it travels vertically up. Here's our very expensive barge and crane to get this thing out. They were on the water for about, I think they're actually on the water about 20 days. Very expensive to do this kind of thing. Basically, when they hit the water, they give you a month, and it's like you finish the job in a month or you don't, and then we charge you for another month. So we really had to work hard to get that done. Interestingly enough, this was done in 2014, and we just gave the customer the bid to repair a different one. So we're hoping we get that work. Here you see the bowl assembly of the pump getting ready to float 3 miles down the river where we had a truck waiting. Each section came out by trailer. Got your nice GE 1250 motor there. All of the columns were left on site for a different trip, but we actually took those columns, sandblasted, and did that Belzona epoxy like you saw on the photo of the impellers as well. So it got a really nice paint job. Switching gears, just so that you all know, these are the brands that we do represent direct. Peerless Pump, Ibarra, which is a Japanese brand, and Gusher Pumps, which are built in Kentucky. Between these pumps, we can confidently offer pumping solutions for a wide range of applications. And a little bit about our approach, if you were sitting in on Justin's opening statements. At HECO, we don't just fix problems, we ask why they occurred. Obviously that is not for electric motors, but we apply that to pumps as well. We try to find the root cause of the equipment issue, develop a solution to prevent it from happening again, and then it maximizes the reliability of rotating equipment.